In this lesson, we're going to learn about similar triangles, and we'll be able to determine if two triangles are similar by comparing their angles and comparing their sides. When we compare the angles inside two similar triangles, they will be equal. So in each triangle, there will be a pair and their angles will be the same. So looking at the two triangles that we have here, we're only given 2 out of the 3 angles inside the triangle. But we can find the third angle by taking our two angles and subtracting them from 180. So if we do 180 minus 50 degrees and minus 60 degrees, we're going to get 70 degrees. So that's the missing angle in this triangle, and we can also find the missing angle in this triangle on the right by taking 180 and subtracting the two angles that we have there. So we're subtracting 60 degrees and subtracting 70 degrees. And when we do that, we get that this angle here is 50 degrees. So since all of these angles are the same, we have 50 degrees, 70 degrees, and 60 degrees in both triangles. That means that these two triangles are similar. When we compare the sides of two triangles that are similar, the sides are proportionate. Each side in the triangle will have a pair in the triangle that is similar. So let me just use colors to coordinate this. If this is the smallest side here in the bigger triangle, this is the pair. It's the smallest side in the smaller triangle. And then this here is, we'll call it the medium side in the big triangle. This is the medium side in the smaller triangle. So those two sides are pairs. And then this is the longest side on both triangles, so these are a pair. So in similar triangles, each side will have a pair in the other triangle. And they're proportionate, so that means the ratio comparing a pair of two sides will be the same for any pair of sides in the two similar triangles. So then we should be able to take any of these bigger sides and divide by the same number to get the sides in the smaller triangle. Or if we're going from a small triangle to a big triangle, we should be able to multiply all of these sides by the same number to get the sides in the bigger triangle if the triangles are similar. And that number is going to be known as your scale factor. So that's the number you can either multiply or divide all the sides in your triangle to get the sides in the other triangle that is similar. So let's compare the sides of these two triangles to see if they are similar. I know that if we take 6 and divide that by 2, we'll get 3. And if we take 12 and divide that by 2, we'll get 6. So that needs to work for the third pair of sides. If we take 8 and divide that by 2, we do not get 5. 8 divided by 2 is 4. So this triangle is not similar because you can't divide all of the sides in the bigger triangle by that same number, by that scale factor of 2. So these two triangles, they are not similar. So let's summarize this in a conclusion. So when two triangles are similar, the corresponding angles are equal. They are the same. Every angle in one triangle will be equal to another angle in a similar triangle. And the side lengths of each triangle are proportional to each other. We can multiply the side lengths of one triangle by a scale factor to get the side lengths of a similar triangle. Now you can multiply or divide. If you're dividing, you're going from a bigger triangle to a smaller triangle. So now let's use what we know about similar triangles to find a missing side in two similar triangles. So these triangles are similar, but we don't know what this side length is. We've labeled it X so far. Each side will have a pair in the other triangle, so I'm going to color coordinate them. These two sides are a pair. These sides on the bottom are also a pair, so it's going to be green. And these sides on an angle will be a pair. But please note that sometimes the triangles might be a little bit rotated, so it's not always as easy as this. To find your scale factor, I think the easiest way to do it is take a pair of your two sides. So I'm going to take the red side here, and we're going to take the longer side, the bigger side, and divide that by the smaller side. So I'll just do that off to the side. We can do 12, divide that by 6, and we're just going to get 2. So that means I know that I can take 12 and divide by 2, and I'll get the smaller side 6. So we should be able to take 5 and divide that by 2, and we'll get x. So 5 divided by 2 is just equal to 2.5. So x is equal to 2.5. And now it's your turn. Here we have the two same triangles, and we've already found the scale factor. The scale factor is 2. So we know if we took 12, divided it by 2, we'll get 6. And then this bottom side here, x, that we just found, is equal to 2.5. I want you to pause the video and find the side length of y. So these two sides were pairs, so once you take 13, divide that by your scale factor of 2, you should get 6.5. So the length of side y is 6.5. Let's do another one, but this time we know all 3 sides in the smaller triangle. We do not know all 3 sides in the bigger triangle. We're finding side x. If it makes it easier, use colors to determine which sides are pairs in the triangles. And you need to find the scale factor, so take a pair of sides where you know both side lengths, and I'm using the green side at the bottom. I'm going to take 6 and divide that by 4. So the bigger side, divide it by the smaller side. So 6 divided by 4 is equal to 1.5, and that's going to be the scale factor. So that just means that any side from the bigger triangle can be divided by 1.5 to get the side in the smaller triangle, or any side in the smaller triangle can be multiplied by 1.5 to get the side in the bigger triangle. Since we're finding a side, the missing side in the bigger triangle, we're going to multiply. So remember, if we took 4 and then multiplied by 1.5, we get 6. And if we took 3, multiplied that side by 1.5, we also get 4.5. So to get our missing side x, we must multiply 2.5 by 1.5. And that will give us x. So 2.5 times 1.5 is equal to 3.75. So our side length x is 3.75.